Algorithm is an effective method expressed in finite list of well-defined instructions in a simple English language. So we write algorithm in a simple English language so that anyone who can read the algorithm can understand what is written over there and which step perform first, which step perform second. So that's why we write algorithm in simple English language so that we can understand it. So once we understand it, we can convert that algorithm to a programming or set of instructions. Starting from initial stage by describing the name of the algorithm. So we always start an algorithm with a particular name with important parameters used in the algorithm and specify the important parameters used in the algorithm within a round bracket. So initial input and instruction describe the computation that when executed proceed through a finite number of well-defined successive states. So initially we describe what uh, variables we are going to use over there and initialize the variable, set some value to that variable that we are going to use in the algorithm and specifies what operation we perform first and what second, eventually producing output and terminating at the final ending state. So every algorithm definitely have some output statement and after producing the final output statement, we have to finish the algorithm with a particular ending state. So some of the characteristics of algorithm, what the algorithm should have. First off is the unambiguous, that algorithm should be clear and unmistakable. We clearly understand what is written on the algorithm, what the algorithm want to state, what we are going to tell, how the algorithm want to solve the problem. So we can easily understand the concept of the algorithm, what the algorithm want to communicate with us, and the algorithm should not have any mistake. If we have any mistake in the algorithm, then definitely we find some errors in the program where we convert the algorithm to a tool. So the algorithm should be very much clear to you and it must not have any mistakes over there. And each of its step and input output should be clear. And the person who read that algorithm easily understand what is written in each and every step. Input, every algorithm can have one or more than one or maybe no input. So that depends upon what type of algorithm we are solving. So an algorithm should have zero or more than one well-defined inputs. Output, the algorithm must have at least one output or more than one outputs. That depends upon what type of problem we are solving. So output, definitely algorithm must have one output at least. So so that we come to know whether we are giving proper output or not. Then finiteness, algorithm must terminate after finite number of steps. So we must finish the algorithm after particular number of steps. So it is not good that our algorithm has steps in hundreds and thousands. So that become not a good algorithm. So our algorithm should get finished in a few number of steps, 20, 30, 40, whatever number of steps. Feasibility, the algorithm should be practicable with the available resources. So whenever whatever algorithm we have written over there, so we can easily convert that algorithm to a program and that program should give us some output. So it should must be practicable to the available resources. Whatever the resources that are attached to a computer can also get some operation whenever we run the algorithm to a program. uh, just 1 second, students. So independent, and algorithm should have step-by-step directions which should be independent of any programming code, because we write algorithm in simple English language, no programming code is being used over there. So we can write any particular language that you feel that easy for you, so you can write it over there without writing a particular coding language. For example, if we use C or C++, then we have to write either printf, scanf or C in, C out whenever you have to go for input or output. Whereas in case of algorithm, you can just write user enter the value, user get the value, user get the value on screen, user get the value on have to enter the value. Fine. Designing of an algorithm. Algorithm design is a method to create a mathematical process in solving a problem. So various steps are, so define the problem. Whenever we have to start, uh, so problem definition. So whenever we have to design an algorithm, so we must understand what the problem is. So we write the definition of the problem, what the problem is, so that we understand. If we understand the problem, then we can write the develop a model. So develop a model for the problem solving. How step by step, uh, right? How we can design the algorithm. Specification or requirement of algorithm. What are the requirements to design algorithm? You can write over there. Checking the correctness of algorithm. You can check whether each and every step is in a sequence. Analysis of algorithm, that is your algorithm is complex or simple. Then implementation of algorithm, you can implement your algorithm in a programming language, any language, C, C++, Java, whatever. Program testing, once you design a program, you can test whether it's giving the correct output. And finally, documentation. Documentation means you can write in paragraph at what you have designed, how you have designed, whether it is giving correct output with proper input, or it is giving wrong output with proper. So this is the structure of the algorithm, that every algorithm has a name. Whenever you write algorithm, always give a name to algorithm. The name of algorithm should match to the statement of the algorithm. In the bracket, you have to mention few important parameters that you have to use in your algorithm. Every algorithm begins with start. First point is start, that it implies that we have started the algorithm. Second, declare the variable used in the algorithm. Define what type of variables you are using in the algorithm: integer, float, character. Enter the value if required. If required, then you can input the value. If not required, you need not input the value. Operation to be performed, whatever operation that has to perform on algorithm, just write on step. If there any condition required, then you can use it. If any loop required, you can use it. And you can go for the printing of the output and then stop the algorithm. This is one of the example of the algorithm, that addition is the name of the algorithm. ABC are the variables used in the algorithm. Let's start with start. Declare ABC as integer. So I declare that the variable ABC are of type integer. Set C is equal to 0. So we declare that initially the value of C is 0. Enter value of A and B. The user enter the value of A and B. So when we run the algorithm, the user can enter value of A, any value of A that must be integer, any value of B that must be integer. So whatever value the user enters, uh, set C is equal to A plus B. So whatever value the user has entered, that's being added and stored in C, and then print C. So after addition of two numbers, whatever value stored in C, that is now printed on screen, that prints C, and finally we set over this stop. This is the you can say example how we can write an algorithm with proper name and parameters. Then start, declare the variable you have used, set the particular variable to a particular value, then ask user to input the value, set the operation, we have performed the operation plus, print C, we give the output and stop. Our algorithm now stop over. Complexity of the algorithm. So what is complexity? So whenever we design the algorithm, some algorithms are easy to understand, some algorithms are difficult to understand. So that one that calls the you can say define the complexity of the algorithm. So important characteristics of algorithm is time and space. So whenever you design an algorithm, either your algorithm take lot of time to access, or it take lot of memory to access. So that depends upon you, which one you give the priority. You give the priority to time, or you give the priority to space. Complexity of an algorithm is a measure of amount of time or space required by an algorithm for an input of size n. So what is complexity? Complexity is a measure of time. how much time the algorithm will take when we give n number of inputs, or how much memory space an algorithm will require when we give the input of size n. The best algorithm of a particular problem is that which require minimum time complexity, or you can say minimum time to complete by its taking minimum amount of space. So let's say that if I say that I am making algorithm, and that algorithm should be finished in least time. So I give priority to time. So I doesn't bother about the space. So I said the algorithm that will take least time according to me is the best algorithm, and the algorithm that will take more time, according to me, that is not a good algorithm. If I say that my priority is space, then I will call that the algorithm that will take least space is good for me. The algorithm with more space is bad for me. So that depends upon you which one you go for, which one you choose. Either you choose time or you choose space. So if your algorithm take more time, it will be not, it is having a more complex. It will take less time. It will be less complex and good for you. Practically, both time and space objective are not possible to achieve this simultaneously. So simultaneously, we cannot say that the algorithm will take less time and less memory. So it is a little bit difficult to achieve. So you can go for any one time, any one thing. Either you go for less time and more space, or you can go for less space and more time. So with this, we can find the complexity of the algorithm. There are various solutions for a problem. One solution may require more time but less space, and another may require less time and more space. So we can solve the problem in two methods. In first method, it will take more time but less space, and in other method, it will take less time but more space. Now it depends upon you which one you go for. You give priority to time or you give priority to space. So if you give priority to time, then you choose second one, less time more space. If you give priority to space, then you choose the first one, that is the more time but less space. The analyst choose the algorithm according to requirement and constraint. So uh, the analyst choose the algorithm according to your priority. You said that choose the algorithm that will take less time. Definitely I will choose the algorithm that will take less time, and I ignore the algorithm that will take more time. If the analyst choose the time constraint to execute, that is to execute the program in less time, then choose the algorithm which take less time but it may take more space. So if I said the analyst that I want the algorithm that will take less time to solve the problem, so analyst will choose the algorithm that will take less time, and he doesn't bother about the space, whether it will take less space or more space. On other hand, if analysts have to choose space constraint, then analysts will go for the option that choose an algorithm which takes less space, but it may or may not take more space. So if I say that the analysts go for the algorithm that will take less space because my priority is space, the analyst will choose the algorithm that will take less space and don't bother about the time, whether it will take more time or less time. So how we can measure the complexity? It can measure with the help of best case, average case, and worst case. So the time required by an algorithm falls in the three categories. Best case, your minimum time required for a program execution. Average case, or you can say worst case, maximum time required by a program to for execution. And average is the average time required by a program for execution of the algorithm. So in this pattern, we can say that our algorithm come under category of best case, our algorithm come under category of worst case, or our algorithm come under category of average case. If I take my priority as time and my algorithm will take a lot of time, then I will say that my algorithm come under the worst case. If my algorithm take very less time, then I will say that my algorithm will come under the category of best case. If it take appropriate time, then I will say that it will come under category of average case. So in this pattern, we can define in which category our algorithm lies in, that is best, average, or worst. So it represented with the help of big O notation, who will represent the complexity with the help of big O notation. When solving a computer problem, will be usually be more than just one solution. So whenever we solve a particular computer problem, so we always have multiple methods to solve the problem. This solution will often be in form of different algorithm and will compare the algorithm to see which one is more efficient. Because we can solve the problem in different methods, so we check all the methods and we check which method will take more time, which method will take less time, which method will take more space, which method will take less space, and what are my priorities. According to my priorities, I will choose that method which is suitable to me. If I say that choose the method that will take less time, then I'll choose that method that will take less time. If I say that my priority is space, choose the method that will take less space, then I will check which one will take the less space, and I select that method. This is where big O analysis help. It give us some basis of for measuring the efficiency of the algorithm. Big O analysis measure the efficiency of an algorithm based on time it takes for the algorithm to turn as a function for input size. So what big O is? Big O analysis always measure the time of the algorithm, how much time it will take. If it will take less time, it will come a category of best case. If it will take very much time, it will come a category of worst case. If it will take appropriate time, then it will come on a category of average case. So perform big O analysis on a function that will run the integer that is smallest in the array. So this is an example in which we have an array and we have to find smallest element in the array. So our problem is to find smallest element in array. How we can solve the problem? We can solve the problem in two methods. First method is algorithm one, that is compare smallest number, and second method is algorithm two, in which again we compare all the numbers. So in algorithm one we use one single loop, and in algorithm 2 we have used two different loops. So it means same problem can be solved in two different ways. One problem will take more time because we have used two loops over there. One will take less time because we have used only one loop over there. Fine. So or definitely uh, the program that will have two loops, that will take more time because it will run two times. Whereas the loop having one loop only, it will take less time because it's run only once. If one loop will take, let's say, 1 minute or 1 minute to complete, then the first problem will complete in 1 minute. And if the second loop is running in two loops, then definitely it will complete nearly by 2 minutes. So it is more than 1 minute. It means it will take more time. So I will say that algorithm one is much better than algorithm two because it is taking less time. So here I define the algorithm that compare smallest numbers. CSN is the name of the algorithm. So these three are the important variables that I have used in the algorithm. I mentioned start over there, declare these are the variable names. CURMIN is the name of a variable, X name of a variable, both are of type integer. I set a loop X1 to 10. So 10 times this loop will run, enter the number. So I enter the number, whatever pattern you want to enter. Then in the first element will be stored in Karmin, and after that again the same loop will run to compare one by one. So what I do is start comparing first element with second element, second with third with fourth. Once the loop get complete, I will find which is the smallest one. So the loop is running only once, whereas in this case okay, uh, the function compares smallest number, that is I having a 10 numbers, and that is input item are each compared to only once when each one is compared to the minimum value. So we compare or find, first initially we said that the first element is the least value and compare the minimum value with all the elements of the array. If we find any element that is less than the minimum value, then that value will be the least value. It means we are checking the loop only once. If we're checking the loop only once, it means we're checking all the elements of the loop only once. So how many elements are there? There are n elements. So it means we're checking n elements only once. It means that I have to scan all the 10 elements. So it means at least 10 times I have to check. In fact, 10 element I have to check. It means the best case will become order of n. That is, I have to check all the 10 elements. It become order of n because in the array I'm having 10 elements and I have to go to each element exactly once and compare each element with the minimum value. If that value is less than minimum value, it means I found the least element. So it means the best case will become order of n. And the linear time means that the time taken to run the algorithm increases is directly proportional number of input output. If I'm having 10 elements, then it will take 10 seconds. Let's say if I am having 30 elements, it will take 30 seconds. It means the time is directly proportional to number of elements you have. More elements you have, more time it will take. You have 10 elements, my problem is solved in 10 seconds. If I'm having 30 elements, my problem is solved in 30 seconds. It means the more you have number of elements, more time it will take to complete. In the second case, I have used two loops. First loop is loop X, second loop is loop Y. So it means two loops are running over there. Again, I am having 10 elements. First loop 10 element 10 seconds. Second loop 10 elements again 10 seconds. 10 seconds plus 10 seconds 10 seconds. I say 20 seconds. Initially, first program is finished in 10 seconds. Second programming is finished in 20 seconds. It means the second one is taking more time. So I will not go for second technique. I go for the first one in which it take only 10 seconds. So this is how we can compare the we find the complexity of the algorithm. So this is all about the algorithm, how we can design the algorithm and how can we can find the complexity of the algorithm and how we can use the big O notation.